Okay, we're looking at binomial expansion, and in the formula book there is NCR or N over R in a sort of long bracket, or you've got the N factorial, N minus R factorial, that sort of thing, alright? But this is basically how it works. So they work the same way each time. So the first term of this is going to be 3 to the 6, so that's this to the power of 6. I always do this a stage at a time plus 6, alright, that again comes from here, right, times 3 to the 5 times minus x to the power 1, right, so it's the first three terms. Now the next one is 6 times 5. Now with the factorials, okay, lots cancels, and this is what you're left with. So you get 6 times 5, and the next one will be 6 times 5 times 4 over 3 times 2 times 1. Okay, so it's just a little sequence, and the reason I always list it out, okay, is because then I can see the sequence. The sequence is really obvious, okay, and even when you have to do slightly harder ones later down the line, okay, the sequence is the same every time. Now notice that, and if I just quickly turn that to green, notice that the powers, alright, so I always add to 6 in each part. So 6 on the first one, 5 add 1 is 6, 4 add 2 is 6. Now I'm going to simplify all that, okay, and obviously going to use my calculator. 729 minus 1, 5, 4, 8x plus 1215x squared, and it only asks for that up to x squared. Obviously it carries on, but there you go, you only ask for the first three. Now another little tip is, do you see where I put this whole thing in brackets here and here? It's worth doing that just to remind you you square the whole thing, not just the x part. Alright, now next question, says we got to do this. So for very small values, the bigger the power of x, alright, the smaller and smaller it gets. So we're basically, if we're doing an approximation using this, then you know, we don't need to go too far on the powers of x. That's essentially what it's saying. Now ultimately the first thing you need to do is expand this, alright, up to x squared, because it says x squared there. Okay, now then we're going to do exactly the same thing. So we get 1 plus 5 times 1 to the power 4. I know 1 to the power 4 is 1 times minus x to the power 1, but again I'm doing this, that's 5 times 4 over 2 times 1 times 1 to the power 3 times minus x to the power 2. Alright, and that will carry on, but we don't need to do anything more than that. Simplify all that, we end up with, what is it, 1 minus 5x plus 10x squared. Okay, and now we're going to multiply our two bits together, and we're going to get this here plus 10x squared. Alright, multiply all that out, we end up with 1 minus 5x plus 10x squared. So that's the 1 times everything in the second, so this 1 times everything here, and the second bit, if I do it in say purple, okay, is going to be 2x times everything in here. So 2x times everything there gives me plus 2x. Alright, oh, I don't know why I'm doing, sorry, let's go back to blue, sorry, do apologise. So plus 2x minus 10x squared, and it goes plus 20x cubed. Now I know I don't need that bit, so I can cancel, because I don't need to go up to x cubed, right? But I just did it because it was there essentially. So when I simplify all that, I get 1. There you go. So it's a therefore is 1, and when I simplify the x parts, I get minus 5x plus 2x minus 3x, right, and the x squared parts plus 10x squared minus 10x squared, no x squareds. So I could say, and I've sort of run out of room a little bit here, I could say that, where shall I put it, a equals 1, b equals minus 3, and c equals 0. Alright, all I would say is that this is just a sequence that if you follow very methodically, and when it gets a little bit harder, it's absolutely imperative that you write down every single stage of what you're doing, because if you don't, you will get things wrong. It's so easy to get things wrong. So my advice is write everything down in the most simplistic form, and then don't do too many stages at once.